Video 6 deals with the drag and drop command as a technique to place textures to obtain greater accuracy in the C runoff coefficient calculation, the composite C for the watershed area. The watershed is cut against these perimeters and textures found within it. And a nice way to define these perimeters is bring in Google Maps as an overlay to find your residential areas, your paved areas, etc. So we'll jump into P3D Hydro and let's discuss where these polylines derived from. So we'll bring in Google Maps. We'll download Google Maps. You must have ahead of time under settings the correct projection set. And the coordinates on the job need to reflect that projection. Then you can download Google Maps. Maybe we'll just do a 2500 buffer size. And it's important to do the drape on the US 68 tin so you'll see it overlay the site. And a second step is to click on the tin and switch it to overlay images, which it's doing, and you can see that these three perimeters define a residential area. This defines a paving area. There's some roofs there, but it's mostly asphaltic paving. So what we'll do is actually delete the Google Maps. That was the basis of drawing these polylines. So we will actually turn off the overlay images so we don't have to see it and go back to show textures. Now we're back to the textured map, and we can actually right click here and delete the Google Maps as a whole. Now what we can do, and it's best to do this with no snaps on. The drag and drop prefers no snaps active. So we're going to go first to paving, and we're going to find the paving option here. There it is. And we'll go up to asphaltic and just drag and drop it on the site. And then we'll switch to another category, TR55 land covers, which include residential areas, which have different, double click, and you can see their C factors. They have different C factors for the density of the residential area involved. Here's a quarter acre lots, here's half acre lots, a 0.54 higher runoff coefficient. And we'll drag and drop the quarter acre onto these polylines. If nothing is highlighted on the polylines, it drags and drops to the selected position, the polygon surrounding the selected position. If you have one highlighted, it will drag and drop to the highlighted polygon. There. So you highlight them by picking them here. You can see the highlighting going on. You can hit escape and remove the highlighting. Now, if we go to the storm event and calculate, this is going to increase our composite C factor. We're going to have more asphaltic area. And even this runoff coefficient is higher than the generic wooded 0.25 land cover elsewhere. It will find that portion of this drive, this asphaltic drive that's within the watershed, and produce the composite. And then when we design here a culvert pipe, the pipe was set to 21 inches before. We can predict it might be 24 inches or even 30 inches. We'll see what happens. Notice that when we hover our cursor in this perimeter, the composite runoff coefficient has moved to 0.421, and look at the asphalt. It's up here to the upper right. There's 2.46 acres of asphalt, and that is pushing the runoff coefficient, the composite coefficient, up to 0.421. The Just Add Bison refers to the forested area. It's just a texture name, and it has 8.4 acres. It's still dominant, but less dominant with these changes that we did. Now, let's design our pipe and see what the result is. We're going to go here and click. Come on down at about 1%. Let's go back to Property Explorer so we can see it. And let's make sure we go downhill at about 1%. We're at 1.6. Let's get in a little closer. Come up the groove there. Change that to -1 exactly. And that pipe is still 21 inches. So not overly affected by that change. We will do one more change, which may reduce the flow, the peak flow. In this immediate valley, the soil is more alluvial, and we can utilize an even lower runoff coefficient.